why are threat actors always putting link files, DLLs, all these things in ISO files? Why are they putting them in VHDs? It's because of mark of the web. It's a piece of metadata which basically is read by the Windows shell. It says this file has been downloaded from the internet, creates a pop-up, warns the user. Honestly, in spite of all of those warnings, users can still click through. Just being downloaded from the internet isn't an inherent sign of maliciousness, and that's one thing that's interesting about human factors is you're not saying this file could be malware. If you were saying that, that's a little bit more of a red flag. It's a little bit more of a stop. It's just saying this was downloaded from the internet. But ISO files, virtual hard disk files, even zip files in some shells can remove mark of the web, that piece of metadata that creates the pop-up that says this was downloaded from the internet. And so that's why these threat groups are using them to deliver their lures, get users to click on them, and continue the next stage of the attack. So this is one of the incidents that was actually mentioned earlier today. The DFIR report published on this incident that led to quantum ransomware. It began with an ISO image. There was a link shortcut file, led to iced ID, led to quantum ransomware. There's no relation between quantum ransomware and quantum builder, which I'll be talking about here. It's just overlap in tool naming. So what is quantum builder? I had a pretty good picture to sort of show you what the GUI of the tool looks like, but it doesn't belong to me. So we'll take a look at another tool which you can kind of visually see what's going on here. But Quantum Builder basically is a tool that's being sold on the dark web to initial access brokers and other people who want to deliver phishing documents, but they don't want to use macro documents anymore because there's this whole thing with Microsoft saying that they're going to disable macro execution by default. Who knows if they're actually going to do it. But threat actors are taking advantage of this change to say macros are dead. And so they're selling this tool and another tool called MLink Builder. And so you put in your payload URLs, whether that payload is an EXE or a DLL or a PowerShell, and it will encode that URL in either an HTML application or a link file. So the link file can actually go out to the HTML application, download that, and decode a PowerShell downloader. We'll go through all the steps. But what the malware author inputs is the final URL of the payload, and what they get out is an ISO or image or VHD file that contains a shortcut file to trigger everything. So they, both of these tools have little marketing things like customizable icons, UAC prompt bypass, decoy files, and we'll get into it and we'll see how they kind of do this, but it is kind of interesting to see cyber criminals advertising their tools like that. So getting a little bit deeper into the weeds here, but this is kind of a high-level overview of how it works. The user mounts the ISO, double-clicks the shortcut. The shortcut file has encoded PowerShell, which executes MSHTA, which is the Microsoft HTML application handler. It basically is, it executes HTML application or browser code. So it reaches out to website number 1, and it brings down this HTML application that is itself obfuscated. And so once that's decrypted, we're still in MSHTA. What's decrypted is typically an embedded VB script that has an encoded PowerShell. And so MSHTA launches PowerShell. PowerShell downloads the final payload, and there may or may not be persistence with a scheduled task, but the final payload is downloaded to disk in app data in almost all of the cases. So you can see kind of at the bottom what the process tree looks like. At the end here, you can see the final payload, and above it is where a decoy file launched with Adobe Acrobat. So this is the GUI offered by MLNK, and I kind of talk about them in the same breath because they offer the same set of features. With one little caveat, MLNK in the top right corner here says they offer shortcut encryption, which doesn't make a lot of sense because if the shortcut was encrypted, it wouldn't launch. When you look at these files, it's just like an additional layer of encryption in the PowerShell. It's nothing too exciting. But they've put it feels like two different writers have put the different GUIs on the same obfuscation framework. So I kind of talk about them in the same breath. And to be honest, be totally intellectually honest with you, I haven't went and bought either of these tools. So the payloads that I'm going to be showing you are based on reporting that were done on the tools, which have connected various IOCs to these tools. But there are different versions of the tools. We're just going to be talking about the techniques that they claim to be using. Okay, so unless I have downloaded these files, downloaded these tools and generated the files, I can't be, totally sure that these tools work. So let's get a little bit, more into the on disk content of these files. So when you open up the ISO, and I've got a little demo for you here. I mean, it's not a demo, but it's a screenshot. When you open up the ISO, you'll see a shortcut file. And I've renamed one of these. This is one of the files that was reported on in the Sybil article, which was depicting Quantum Builder. And the icon is customizable. I've opened up the properties so you could look at the target. But if you saw this within an ISO file that you had just uploaded, that you had just mounted, you might think that you need to click the shortcut again in order to get to the drive. So that's how it can be convincing to the user. In this case, it's interesting that you can see the PowerShell in the target, but they've actually put enough hash signs, comment marks to where it overfills this buffer and you can't actually see the code. So it's interesting that they've kind of done that to keep you from seeing what it does. So the link file, like I said, it has encrypted/encoded PowerShell, and the HTML application also, it has embedded JavaScript, and that just creates a wscript.shell object, which launches additional PowerShell. It's just kind of like a, more vehicles for PowerShell all around. So this is what the shortcut file looks like if you just run strings on it and decode the Unicode, because this is all wide strings. It's a very simple algorithm. They just have a list of numbers, right? And they subtract a given value from it, and then they turn it into a character array. So on the bottom two lines, I kind of have what this whole thing decodes to. The advantage of doing this kind of obfuscation is that you hide things like the keyword invoke expression, which kind of identifies this as being PowerShell. IEX is something you'll also see kind of hidden because antiviruses will kind of be detecting on those keywords. And so they'll encode them using an algorithm like this and then do set alias so that they can use invoke expression without being observed. But it's a pretty simple algorithm for a human to see, but I guess it has some kind of effect on antivirus. And then let's go into the HTML application. This is as deep into the obfuscation as things really get. So the HTML application, in short, it does the same subtraction algorithm. It's a bit tough to read, but once you notice that you have an array of these numbers, again, you just find the key, do the same thing, and then you're typically, there was one sample where there was an additional layer of obfuscation, but typically you've made it to the last PowerShell layer, which is the downloader. So this all of these stages are present in all of the quantum builder samples. They're present in all of the LNK samples. And the point is to get to this PowerShell downloader, download a final payload, potentially register a scheduled task for it, and then launch a decoy. So once you decode the URL, you can see what the final payload is. There may be some extra obfuscation, as I mentioned. It's some typical PowerShell stuff where you base64 encode a string of bytes, and you have an embedded key, and you decrypt it using the AES algorithm, and then you gzip decompress the bytes. But it's not something that is hard for most security tools these days to follow, or analysts. So you've made it to this last stage. You've downloaded the final payload. What usually are those payloads? So both of the tools seem to support execution of DLLs, EXEs, PowerShell. What I found looking at all these samples and hunting for them is that typically they were dropping iced-ID, Redline, Qbot, some versions. I wasn't sure if these were associated with MLNK or Quantum Builder. Some were dropping NetWire, WSH RAT, which is a Windows script host type of RAT. It's just another stage of HTML application in VBS. So these are the banking Trojans that we would, call the middle of the ransomware kind of kill chain, because after that comes Cobalt Strike, after that comes Sliver, in the same breath, Cobalt Strike, Sliver, other lateral movement techniques, and then ransomware. So these are the initial access brokers. A lot of different examples, and So I wanted to talk a little bit about some of the framing around these tools, because I think when people are in a rush to publish something about some new tool that's on the cyber criminal market, they can kind of conflate things. They can say that there's overlap with some campaigns. For example, Lazarus in this case, which is an APT. I was reading the article that Sybil referenced that was trying to tie Quantum Builder to Lazarus. And so I read the article they referenced. It's this Onhen cert. And they were tying this Operation Dream Job campaign, which was definitely Lazarus, to the lures from a campaign that clearly used Quantum Builder. And so there wasn't much overlap there. So, to be honest, I'm really very distrustful of any association between this tool and Lazarus. I don't really think that there's much of any connection there. Lazarus typically brings their own custom tooling. They bring compiled malware. You don't really just see them dropping stealers from PowerShell. But I'm not a threat intel expert, could be wrong. And so the attribution of this tool is it's not very obvious or tied to any particular APT. And I made this slide because I think that when cyber criminal actors pick up on the fact that we are trying to link APT techniques to something that's very simple like this, they take advantage of that in their marketing, and they say, oh, APT actors are doing this now, you should buy our product. That gains them more popularity, and it's generally bad. But in this case, there didn't seem to be any association, and so thought I would add that in there. I thought I was about done and ready to make a YAR signature. Well, I had made a couple of YAR signatures already. And I found a kind of like new version of the link file. And they had basically changed their obfuscation method. Now, after looking at some of the metadata between the link files that I'll go into at the end, I was noticing that you had one major push back in May of this year, 2022, and one major push further into July. And so There was a bit of clustering to be done there, but basically, instead of just having like an array of integers and then subtracting off one key, they actually have a character bank, and so they have like a bunch of characters, and they have an algorithm for selecting the proper character in order to build the string that they want to build. This is, definitely a little bit more of an advanced technique, and it takes a little bit more work for an analyst to decode. Of course, if you have some kind of PowerShell logging on, you're probably okay. But it was interesting because it wasn't something that I could see unless I were pivoting backwards from the HTA files. So the HTA, we have 3 stages here. It's the link file, it's the HTML application, and the PowerShell downloader, right? So if the HTML application stage and the PowerShell downloader remain the same, but the link file changes, it's clear that they're either iterating on a tool, but keeping some other stages the same, and we can make a bit of a connection there, or they're getting detected, or they've been in the news too much. So it's really important to have even in we're just talking about early stage malware here. We're not talking about all 3 stages of the malware chain. It's important even in just this one tool to understand how the different pieces of it are changing. This is all, and it's interesting because it's all kind of asynchronous. So for example, this is the first stage in the payload. It reaches out to this HTML application. If that website comes down, we don't know what it delivered. And so in some ways, there are more points of failure for an attacker if we can take down websites that look like this. But it also creates holes in our intelligence, for example, if we can't figure out what was hosted there. So these are a couple of the rules that I wrote, and if we're going to talk about detection opportunities, ER signatures are going to be okay for hunting, but they're not necessarily going to be enough. We kind of know that they are going for a particular process tree. We know that it's MSHTA, and the reason why they're doing that is because we have, in terms of what we have on disk versus what we have in memory. So we have the ISO file, which contains the shortcut file, which were downloaded, right? Those are on disk. You can't rely on the antivirus to just scan a shortcut file that you just mounted from an ISO. And so they're taking advantage of that fact. When you launch the shortcut and it launches MSHTA, and it reaches out to that remote HTML application, that happens in memory, okay? So the HTML application doesn't come down to disk. So that decodes, it runs more PowerShell. That PowerShell is also in memory, not on disk. And that downloads the final payload. For some reason, they download it to disk, but there are your artifacts. There's reasons why they wanted most of that to be in memory. And if we could rely on that last stage payload, like iced ID or redline stealer being detected by antivirus, well, none of these attacks would be happening. They have packers, they have cryptors. They're not necessarily being caught by antivirus. So it's important to note that for these, the final payloads are typically in the app data folder, but that's for now. They could do more in memory if they knew how to do it or wanted to do it. But it's important to understand that we only have something at the end on disk and something at the beginning. And also the UAC bypass that they kind of advertised, it's something that you can look up online. They add a couple entries to the registry in order to bypass the UAC prompt that comes up when you run PowerShell. Nothing super fancy there. I only had 1 or 2 samples that actually registered scheduled tasks, so might not be the greatest detection opportunity. But like I said, we have 2 different network requests that are involved here, so there are opportunities to catch it at the network level. We've kind of gotten to the end of the formal, like, technical part of it, but love to answer questions. This is a metadata slide for Harlan because he's always on LinkedIn asking, whether anybody's tracking shortcut file metadata. And so I basically went through every file I had, around 200, and I just ran LECMD on all of them. I was trying to look for trends in machine ID or MAC address or any of the artifacts, and it definitely kind of did help cluster some of the campaigns. And I was surprised that with a tool that's supposed to generate shortcut files, it's a very simple file format. You can just put all the bytes together. You don't have to have this metadata in there. You could just zero all that out. The file would still work. But it's just interesting to see that all of these things were left. And you got a guy who's calling researchers stupid, and I mean, I cropped out some of the worst language, but it's interesting to think that this person generated several link files and their machine ID and MAC address were on all of them. So I mean, this kind of, a couple ideas like that, from forensics is always very helpful in malware. But that is all the formal portion I have, and happy to take questions. Awesome. Go ahead.
What does the shortcut encryption do different from changing an encryption from EXE to AA?
Sure. So the question was, what does the shortcut encryption kind of do? Like, what does it accomplish? I mean, the thing that's interesting to realize about shortcut files is that they can kind of do anything because of the way that they're handled. They can launch all kinds of programs from different directories. But for the most part, besides some headers and some metadata, a lot of them are text. So the arguments, the command line arguments that you can pass to the executable are just text. So, when an antivirus is scanning through a shortcut file to try to find some PowerShell-like things, they're looking for text typically. So hiding that text is effective in evading some scanners. Now, I will say, detection-wise, on VirusTotal, if you look at all these hundreds of samples, they're detected pretty well. But that didn't help when I was, mounting an ISO, executing it. The Defender doesn't catch it. Whatever the VirusTotal is saying is not really relevant, right? Because if it didn't work, they wouldn't be doing it. So, other question? Sure. This is a good question. Yeah. So the question was about mobile malware. How does Reversing Labs detect mobile malware? I want to work on more mobile malware, but so mobile malware, you need either a pretty decent sandbox environment, or you're statically analyzing the jar and the dex classes files. I don't really know to a great extent how Reversing Labs handles Android or iPhone apps, but I'll find out and get back to you. Any other questions? All right, thanks.